Hi folks, welcome to another lesson. We're going to be simplifying surds and we're going to be multiplying surds today, and you may not even know what a surd is, so I'm going to explain that. Let's crack on and get the job done. A surd is a root of a number that cannot be expressed as a fraction. So for example, root 16 is 4, which can be written as 4 over 1. Root 9 is 3, which can be written as 3 over 1. So they are not surds, but root 2, root 3, root 8 are examples of surds. And roots obey the following rule. Root A multiplied by root B is equal to the root of AB. Now let's put numbers into that and check it. That would mean that root 4 times root 9 equals the root of 4 times 9. So that would mean that root 4 times root 9 is root 36. Well, root 4 times root 9 would be 2 times 3, and root 36 would be 6. So yes, 2 times 3 equals 6. That's correct. Now, we're going to simplify surds using this rule. And we are looking for factors of the number, which is a square number. Remember what a factor is? A factor divides into a number. So let's have a look at an example. Root 50. Can you think of a number that divides into 50 that is a square number? What is the biggest square number that divides into 50? And the answer to that question is 25. And so we can rewrite root 50 as root 25 times root 2 using the rule in the yellow box. And root 25 is 5, so we can write that or simplify that as 5 lots of root 2. Let's have a look at another example. Root 20. What is the highest square number that divides into 20? The highest square number that's a factor of 20. And the answer to that question is 4. So we can rewrite root 20 using the rule as root 4 times root 5. And the square root of 4 is 2, so we can write that as 2 root 5. In our second example, the square root of 32, what is the highest square number that divides into 32? Well, 4 divides into 32, but it's not the highest square number. The highest square number is actually 16. So we can rewrite using the rule root 32 as root 16 times root 2. And the square root of 16 is 4, so we can write that as 4 root 2. Let's look at these two examples then. In the first example, 3 times root 2 times root 2, we compare up the root 2 and the root 2. Root 2 times root 2 is root 4, which is just 2. So you can either think of it as root 4, or you can think of it as the two square roots cancelling each other out to make 2. Okay, a square root of 2 times a square root of 2 is just 2. So that then just becomes 3 times 2, which is 6. In our second example, we can write 5 root 3 as 5 times root 3 and 2 root 2 as 2 times root 2. And we put the whole numbers together and we put the roots together. So the whole numbers together we can write as 5 times 2, and the roots together becomes root 3 times root 2. Well, clearly 5 times 2 is 10, and then using the rule, root 3 times root 2 is root 6. So we get 10 and then root 6. The square root of 30 times the square root of 5, using the rule, we can just write that as the square root of 150. Now we try to simplify that by asking what is the largest square number that divides into 150? And the answer to that is 25, because we can write 150 as 25 times 6. So the square root of 150 is the square root of 25 times by the square root of 6, and the square root of 25 is 5, so we can write that as 5 root 6. A second method of doing this, and you can choose which method you wish, is factor spotting, and that means spotting that in root 30 we have root 5. 5 is a factor of 30, so we can rewrite root 30 in terms of root 5 times root 6. So root 30 times root 5 becomes root 6 times root 5 times root 5. That bit there is root 30, and then we can put the root 5 times root 5 together. The square root of 5 times the square root of 5 is the square root of 25, which is 5. So we end up with root 6 times 5, which is 5 root 6. The square root of 40 times by the square root of 5. Method 1, we would multiply first, so that would become 40 times 5, the square root of 200. What is the largest square number now that divides into 200? And there are quite a few square numbers that divide into 200, and the largest of which is 100. So we can write that as the square root of 100 times the square root of 2, and the square root of 100 is 10, so we get 10 root 2. Method 2, factor spotting. If we look at 40, we can see that root 5 is in there, so we can rewrite root 40 as root 8 times root 5. So we end up with, that's root 40 highlighted in yellow, and then we put the root 5 times root 5 together, and that makes root 25, which is 5. So we end up with 5 root 8. Now you can see that 5 root 8 is not the answer we've got using method 1, and that's because we can simplify root 8. We can break root 8 down by asking what's the largest square number that goes into 8, and the answer is 4. We can write root 8 as root 4 times root 2, and then root 4 is 2, and so our final answer is 5 times 2 times root 2, which is 10 root 2. Let's put this all together in a recap. A surd is the root of a number that cannot be expressed as a fraction. So root 2, root 3, root 8 are all examples. It doesn't have to be a square root, it could be a cubed root, etc. But in this section, we've just worked with square roots. Surds abide by this rule, where root a times root b equals the root of ab. So for example, we can write root 50 as the product of two other surds, and we ask ourselves the key question: what is the largest square number that goes into 50? And the answer to that question is 25. So we can rewrite it as root 25 times root 2. And the reason we use square numbers is because when we square root a square number, we end up with a whole number. So we end up with 5 root 2 in this case, and that's our final answer. We can also multiply and simplify for surds at the same time. So root 40 times root 6, if we multiply that up, that's root 240. To simplify it, we ask ourselves, what is the largest square number that divides into 240? And the answer to that is 16. It's 16 times 15. And the square root of 16 is 4. So we can write that as 4 root 15. And if there's anything about the video you haven't understood, just watch it back. And if you have, that's great, because that's the job done.